The ultimate math roadmap for AI, from beginner to researcher, artificial intelligence, AI, is transforming the world from powering smart assistants and self-driving cars to revolutionizing healthcare, finance, and education. But behind every AI breakthrough lies one common foundation: mathematics. For beginners, math might seem intimidating, and many wonder, do I really need to know advanced math to work in AI? The truth is, the level of math you need depends on your goals. If you just want to use AI tools, only the basics are enough. But if you want to build AI models, or even push research forward, you'll need to dive deeper into the mathematical concepts that make AI possible. In this roadmap, we'll explore the step-by-step math journey for AI, starting with the essentials and gradually moving into advanced topics. Along the way, we'll also see why each area of math matters and how it directly connects to real-world AI applications. Whether you're a curious beginner, an aspiring AI engineer, or someone dreaming of becoming an AI researcher, this guide will help you chart the right learning path. Artificial intelligence, AI, feels like magic, but the real fuel behind it is math. The big question is, how much math do you actually need to learn for AI? The answer depends on your goal. Do you want to use AI, build models, or push AI research forward? This blog breaks down a complete math roadmap from beginner foundations to advanced research-level topics, so you'll know exactly what to learn, why it matters, and how it's used in AI. Why math for AI? No math, you can use AI tools like ChatGPT or Copilot. Some math, you can build and train models. Deep math, you can research and invent new AI systems. Think of math as the engine that powers AI. The deeper you go, the more control you have. Stage 1. Foundations. At the beginner level, you don't need advanced math. Just a few basics will help you understand how AI works and make sense of data. Algebra. Learn equations, functions, logarithms, and exponents. Example. When AI normalizes data, it's using algebra to scale numbers into a desired range. Geometry, trigonometry. Basics of vectors, distances, and angles. Example. In computer vision, calculating the distance between 2 points in an image is just geometry. Basic probability statistics. Concepts. Mean, variance, standard deviation, normal distribution, conditional probability. Example. Spam filters calculate the probability that an email is spam based on certain words. Resource. Khan Academy. Algebra. Probability statistics. Stage 2. Core AI math. This stage is the heart of AI math. If you want to build or train AI models, you must learn linear algebra, calculus, and probability in more depth. Linear algebra, the language of AI, topics. Vectors, matrices, dot products, eigenvalues, eigenvectors. Example. A neural network's weights are stored in matrices, and multiplying them with vectors of inputs produces predictions. Calculus, the engine of learning. Topics. Derivatives, partial derivatives, chain rule, integrals. Example. Backpropagation, the method neural networks use to learn, is powered by derivatives through the chain rule. Probability statistics, deeper. Topics. Random variables, distributions, normal, Bernoulli, Poisson, Bayes theorem, expectation, variance, covariance, hypothesis testing. Example. Bayesian inference is used in many AI models, including natural language processing. Resources. Linear algebra done right. Sheldon Axler, MIT OpenCourseware. Multivariable calculus, linear algebra. Probability for machine learning, Kevin Murphy. Stage 3. Applied math for AI. Once you've mastered the core math, you can explore applied math to design better models and training techniques. Multivariable calculus. Learn about gradients in higher dimensions. Example. Optimizing a model with many parameters is just finding the minimum point of a complex surface. Optimization. Topics. Gradient descent. Stochastic gradient descent, SGD. Atom optimizer. Convex optimization. Example. Every time AI updates its weights, it's performing an optimization step. Information theory. Topics. Entropy. KL divergence. Mutual information. Example. Transformers. The architecture behind ChatGPT Use information theory to calculate attention weights. Numerical methods. Topics: matrix factorization, iterative solvers. Example: used in large-scale training to make computations efficient. Resources: convex optimization, Boyd-Vandenberg. Deep learning, Goodfellow, Bengio-Courville. Stage 4, research-level math. If you want to innovate and push the boundaries of AI research, you'll need advanced math. This is where things get theoretical. Real analysis measure theory provides the rigorous foundation for probability theory. Example: ensuring that probability distributions behave correctly in continuous spaces. Functional analysis studies infinite dimensional vector spaces. Example: used in advanced AI models that approximate functions. Graph theory. Example: graph neural networks learn from data structured like social networks or molecules. Differential equations. Example: neural ODEs, which solve problems by treating model layers as continuous functions. Advanced probability. Topics: Markov chains, stochastic processes, martingales. Example: reinforcement learning relies heavily on Markov decision processes. Resources: probability and measure, Billingsley. Research papers on graph neural networks, neural ODEs, shortcut mindset. Want to be an AI engineer? Practical, applied. Focus on linear algebra, calculus, and probability. Want to be an AI researcher? Continue through the full roadmap. Final thoughts. You don't need to master all of this at once. Start small, apply math directly to AI projects, and level up as you go. Remember, every piece of math you learn unlocks more power in AI. With this roadmap, you can go from AI user to AI builder to AI innovator. Conclusion. Mathematics is the hidden language of artificial intelligence. From simple algebra to advanced probability and graph theory, every level of math unlocks new possibilities in how you can understand, build, and innovate with AI. The key takeaway is that you don't need to learn everything at once. Start small with algebra, geometry, and basic probability, then move step by step into linear algebra, calculus, and optimization as your projects demand. If your goal is practical AI engineering, focus on the core trio: linear algebra, calculus, and probability. If you dream of pushing the frontiers of AI research, keep climbing through the full roadmap into more advanced areas. Remember, every equation, every graph, every formula you learn brings you closer to mastering the engines that power today's smartest technologies. With patience, practice, and curiosity, you can go from being just an AI user to an AI builder, and maybe even an AI innovator.